Hello all, welcome to lesson 6. The topic today is trig limits and limits using the calculator. Before you get started with the do now, I want you to actually copy all the notes that I gave in the video before. So please do that so that you have access to them and you're using them. They're notes of literally from lessons 1 through 6. So please make sure you have the notes in front of you. So let's get started with the warm-up. It says evaluate each of the following limits. So the first method is always to use direct substitution. If that doesn't work, then you use the other methods. So here, if I direct substitute limit as x approaches 0, so it'll be cosine of 0, the square goes here, over 2. What is cosine of 0? We should all know that cosine of 0 is 1. So what's 1 square? Just 1. So the final answer is 1 over 2. Number 2. So for this one, limit as x approaches infinity, we cannot use direct substitution when x is approaching infinity. So we need to look at the graph. I already graphed this sine function. It starts at the midline. And we know it oscillates between 1 and -1, right? Our range is from -1 to 1. So here it's saying limit as x approaches positive infinity. So as x is going to the right, what's happening to my y values? They're oscillating between 1 and -1. So our answer is does not exist. I want you to take a moment and copy these special limits. There are two special trig limits that we need to know. This is one of them. I'm just going to box it. This is one of them. And this is the other one. So these are the two special limits. Limit as x approaches 0, sine x over x is equal to 1. Remember, whenever we're working with these limits, I want you to focus on this. They have to be the same, right? And similarly, sine 2x over 2x will also be equal to 1. Sine 3x over 3x will also be equal to 1, and so on. The second special trig limit is limit as x approaches 0, 1 minus cosine x over x is equal to 0. You have to memorize these, so please know that. And similarly, 1 minus cosine 2x over 2x, 1 minus cosine x squared over, I just didn't fill this in, it has to be x squared and so on. Again, if you've noticed, I'm just going to do it in light. This part is same. So this have to be same. So I want you to highlight that, okay? They're going to be equal to 0. Okay, so many other limits can be found by rewriting them to look like the limits given above or by using previous methods that we've been doing, and the notes also you must have seen. So let's get started with our examples. Our example 1 is given to us. I rewrote it by separating my constant, which is 3 over 2, and this is what? My special limit, right? Sine x over x is what? Just 1. So I'm going to apply the limit. Limit of a constant is just the constant. So 3 over 2 times 1, which is 3 over 2. So my answer, number 2. Limit as x approaches 0. This has a cosine function. So think about your second trig limit that we learned. Can we make this look like the one above? So look here in the numerator. Can I rewrite it limit as x approaches 0, and I can factor the 4 because I wanted 1 minus something. 1 minus cosine 2x over. Can I write 6x because I wanted this and this to be same, right? So this is 2x. Can I write 6x as a multiple of something times 2x? Yes, I can. And that would be 3 times 2x, right? It's the same thing. It's just breaking it down. So I know that this little thing is what? 0, right? So it's going to be 4 over 3 times 0, which is 0. So my answer to this question is 0. Number 3. So this does not look like a trig limit because there are no trig functions, you rightly guessed, right? If I do direct substitution, I get 0 over 0, so this is not going to work. I can't factor, cannot simplify, so the fourth option I'm left with is rationalizing. So what are we rationalizing here? We're rationalizing the numerator. Oops. Oh, sorry. Okay, so how do we rationalize? This was one of the questions that a lot of students were asking me. So here, you look at this sign. These are your two separate terms. So whatever the sign between the two terms is, you multiply and divide. You will have the same terms, but it'll be the opposite sign. That's how this is called the conjugate. So you multiply and divide by the conjugate, right? So now in the denominator is going to be pretty simple. So this is going to be, nothing's going to multiply out. So it's going to be x minus 1 times square root of x plus 1. In the numerator, what happens here? This is difference of two squares, right? It's like a minus b times a plus b, which is a square. So it will be what? Just x and b square minus 1 square, which is 1. So what happens? X minus 1 cancels out with x minus 1, and what are we left with? Limit as x approaches 1 over square root of x plus 1. Once you're done simplifying it, then you do direct substitution. Now substitute 1 for x, so I have 1 over square root of 1 plus 1. Square root of 1 is just 1, so 1 plus 1 is 2. So our answer is 1/2. I want you to finish the practice problems and the homework and upload it onto Canvas.